This is Algebra 2 with trig. This is section 13.2, day 1. We're looking at angles and we're also going to look at radian measure. In the past, we've been talking about angle values for acute angles. In this lesson, we're going to talk about angles that can be much larger than that. We have an initial side and a terminal side of these angles. A terminal side lays on the x-axis, and then we'll open up that angle, and that is called you have an initial side, and now we're going to have a terminal side. The angle can be formed by fixing one ray, called the initial side. That's along the x-axis. And rotating the other ray, called the terminal side, about the origin. This is called standard position. When you have a vertex in the center and you have a side down the positive x-axis, that's called in standard position. In geometry, you may have graphed polygons in standard position. The standard position of an angle whose vertex is at the origin, and the initial side is on the positive x-axis. So we're going to try to graph some of these. So these are just approximations on where the graphs are, but 240. Well, if 0 is along the x-axis, 90 degrees is coming up to the y-axis, 180 degrees. So then we need 60 more degrees. So we're going to go past 45 more degrees. So we're going to come down to approximately here. That would be about 240 degrees. 500 degrees, you would start, come around to 180, around to 360, add 90 more of that to get to 450. At 450, you need to add 50 more degrees to that. So that would be 500 degrees. Notice that if that's 50 degrees extra past that 450, then 90 plus the 50 would be 140. 140 would be going in the same exact direction as 500. We'll talk about those types of angles shortly. Negative 50. Well, a negative angle is not going to go to the positive direction, not going to go counterclockwise. We're going to go clockwise. So 45 would be right through with the slope of 1. We're going to be more than that. So here we would have negative 50 degrees. In example 1, the angles 500 that we talked about and 140 were considered coterminal. Coterminal angles, because their terminal sides were right together. An angle coterminal with the given angle can be found by subtracting or adding multiples of 360. So one way we could be up here, we could take the 500 and subtract 360 from it, and you would get 140. We measured it initially 90 plus the extra, 90 plus the 50, to come up with 140. but you could also do it working with adding or subtracting multiples of 360. So we'll come down here and try to find a positive and a negative angle that is going to point in the same direction as our negative 215. Well, negative 215 should come down. It's past negative 180, and it's up about 35 more degrees. That would be our negative 215. The picture just gives you a good visual. You really don't need to draw them, but if it helps you visualize and see what's happening. What other angles land right there? You could come up this way. So 90 plus something else would get us to go there. You could take 180 and subtract that 35. Or you could take the 215 and add the 360. So there's multiple ways for us to see how to get there. We have the negative 215 and we're adding the 360 to it. That gives us 145. So an angle of 145 would be going in the exact same direction. They're called coterminal. Well, what would be a negative angle? If we took the negative 215, we couldn't go any less than negative 215 because that wouldn't land in the same spot. We have to go a whole nother circle in the same direction, which is considered a negative 360 to give you a negative 575. Both of those are coterminal to each other and also coterminal to the 215. There's really an infinite number of coterminals to 215. We could just keep adding 360, 360, 360. Let's try 540. Oh, 570. 570, it's in the positive direction. So 360, 450, 540, so 30 more degrees would point off in this direction. So what's another way that we could land in that exact location? Notice how we went over 360. We went more than a full circle. So to get a positive coterminal, I could actually subtract 360. And I'm still going to get a positive angle. You could add it and get a really big angle, but you could also stay between 0 and 360, and that's still considered a positive. To find my negative, I'm going to have to subtract the 360 once, and then subtract the 360 a second time. And that would give us our negative 150. So if we look here, 570 is 540 plus 30 more. Well, negative 180 and 30 back would put you at the negative 150. So your answers are making sense to other ways to calculate it. Let's look at 395. 395 is a positive angle. But look, it's over 360. So one way to get another positive coterminal is to take the 395 and subtract 360 from it, and you'll get the answer of 35 degrees. If you take your 395 and subtract 360 from it, we get our 35. Subtract 360 from it again, and we're going to get negative 325. Those angles are all considered coterminal with 395. Negative 45. You have negative 45. To find a positive value, we would have to add 360 to it. So to add 360, we'll get 315. So instead of going the full way around, we go the full way minus 45, which is a negative 45. Well, another way to get a negative coterminal is to subtract 360 degrees more, and that gives us a negative 405. That's a coterminal that points in the same direction as a negative 45. On the other side, we're going to talk about radian measure. Well, radian measure is a measurement for an angle. We currently use degrees. Degrees is a way to compare angles or give us a measurement for an angle. Well, there's a different way to measure, and that's called radian. It's similar to like inches and centimeters. They're different, but they can measure any length. Well, for an angle, we have degrees or we have radian. Now, what is a radian? A radian is when you take the radius, the length of the radius, and you stretch that out over the circumference. So you have an arc that's on the circle, the same length as the radius. So if r is your radius, the arc that's going to be formed by the radian is going to be equal to that of your radius, and that gives you 1 radian. In a circle with radius r, centered at the origin, 1 radian is the measure of an angle. In standard position, whose terminal side intersects the arc. Here's a computer program, Geometry Sketchpad, that's going to help illustrate kind of what a radian is about. We have a circle, and we'll come up and we'll draw in the radius of that circle. So now, to represent what a radian is going to be an arc along the circle that is the same length as the radius. So here we have a arc the same length as our radius. On the side, we have some measurements that show that the arc length is 4.95 and our radius is also 4.95. So as we watch both of them grow, you can see that our numbers change. And they're growing at the same speed, and they both end. Don't follow the letters. That was just by making the program. If I made the circle bigger, those would be changing with it. See if I can grab something that's going to move this. So if I make it bigger, you can see up here that the arc measurement and the radius are both getting bigger or smaller, all together. So when we open up this arc, the same size as the radius, we get what's called a radian. So we have 1 radian. The question is, how large is this radian? We can look at the degrees that it would take to calculate that. So as that grows, we see that the angle being made increases up to 57.3. The perfect calculation is 57.29. That is the degree value of 1 radian. It doesn't matter the size of the circle. If I come over and grab my radius again, you can see up here on the side that that angle of 57.3 is staying exactly the same all the time. It doesn't matter the size of the circle. So that's 1 radian. Well, how many radians fit around an entire circle? Well, let's go back and think about a diameter. How many diameters fit around an entire circle? We learned in geometry class about the number of diameters that fit around a circle is the number pi, 3.14. You can fit 3 diameters around the edge of the circle plus a little bit extra. That would be the 0.14. So if there are 3.14 diameters that go around a whole circle, how many radiuses are going to fit around a whole circle? So what we can look at here, we would have 1 radian, 2 radian, 3 radian, 4, 5, 6 with a little bit left over. If there are 3.14 diameters, when you start to measure with a radius, there's going to be more of them. There's going to be twice as many of them. So if it was 3.14 for a diameter, it has to be twice that, 6.28. The number of radian for a full circle, you'll see, is 6.28. Another way to phrase 6.28 is just to call it 2 pi. So instead of calling a circle 360 degrees, we're now going to call a circle 2 pi. So if the circle is 2 pi all the way around it, what would it be to get to the diameter? What is the angle value in radian to get over to where 180 usually would be found? If it's 2 pi to become all the way around, it would be 1 pi to get over there to the 180. So now we have 2 pi for the full circle. We have 1 pi to do our half circle. So the number of radian in a semicircle would come out to be 3.14. So we can measure many other spots along a circle. When we learn about the unit circle in the future, we're going to talk about several other locations at 30s, 45s, 60s, and all the multiples to go around the full 360. What are all the radians? Some of those radians are going to be less than 1. Some of those radians are going to be more than 1. I just realized that my video there with the computer was upside down for you most likely. But nonetheless, you got an idea. It's a circle. It's both ways, top and bottom. Well, we're going to be converting from degree to radian. So there's 2 ratios that we can use. Notice that they're both dealing with pi and 180 because that's a value of 1 to each other, because pi, 3.14, is the same thing as 180 when we're talking about the radian measure. So if we want to convert 210 into radian, we can say put radian on top, put the pi on top, put the angle on bottom. Those are your degrees. So your degrees can cross out. Your zeros can cross out by dividing it by 100. 3 can go into 21 7 times, and 3 can go into 18 6 times. So this is really 7 pi over 6. So you can see that that's more than 1 pi. That's more than 180 degrees. If we have 5 pi over 4, we're going to times that by a ratio. This time we put the pi on bottom so the pi's can cross out. 5/4 of 180. 4 goes into 4 once. 4 goes into that 45 times. And we come up with negative 225. Our 330 converted into radian, so we put the radian on top, we put the degrees on bottom. We can cross out our multiple of 100. 3 goes into 33 11 times, and 3 goes into 18 6 times, so we're going to get 11 pi over 6. 17 pi over 6, we would start out with 180 on top, because we want to convert it to degrees, with pi on bottom, cross the pi's out. 6 goes into 6 once, 6 goes into 180 30 times, and when we multiply that, we get 510. One thing I want to warn you about is don't work on converting all your problems. Don't make that be your big plan that you're going to convert all your radians to degrees. Work with it and convert it back. That's not how we work with radian. You have to learn to deal with radian and read radian without always converting it. That's a major misconception, and people will have troubles later on when you have to work with the speed test.